This is our second problem on kinematics, one-dimensional motion, and this problem is continuation of our problem 1. We have a rocket-propelled car, initially at rest. It has its engine fired at time moment 0. The car accelerates with acceleration that is proportional to time, alpha t, alpha is constant. After 2 seconds, that's a new part for us. After 2 seconds, the rocket shuts off and the car has no acceleration. So here, after 2 seconds, acceleration is 0. What we are looking for, let me erase this also. We are looking for velocity and position as function of time, and we're also looking for position at 2 seconds. But most importantly, let's find velocity and position as function of time. So what do? I hope that you have our formulas that we derived in the previous videos in front of you. And now, since we have 2 different accelerations, from 0 to 2 seconds, we had alpha t. At time greater than 2 seconds, we have acceleration 0. We break this problem into 2. So what is our first problem? Our first problem is time less than 2 seconds. We know acceleration. We solved this problem in the previous video. We integrated the acceleration to find velocity as a function of time. What was the result? It was alpha t squared over 2, and the constant was 0 because the car was initially at rest. We also integrated velocity to find the position. It was alpha t cubed over 6, and the constant of integration was 0 because the car starts at the origin. Now we need to consider our motion at time greater than 2 seconds. At time greater than 2 seconds, the acceleration is 0. What I want to do, I want to find out my velocity, the velocity of the car and position of the car at 2 seconds. And then we will keep going. What is the velocity of the car at 2 seconds? It is Vx at 2 seconds. Alpha is 3. T is 2. 2 squared is 4. Divided by 2. 12 over 2, it is 6 meters per second. And since acceleration is 0, since acceleration here is 0 at time greater than 2 seconds, that's motion with constant velocity, that is 6 meters per second. Now we need to find the position at 2 seconds. The position at 2 seconds, I bring 2 here, then I have alpha 3, then 2 cubed is 8, and divided by 6, it gives me 4 meters. That's the position at 2 seconds. From now on, I have motion with constant acceleration. We have choices. Either I use formulas for constant acceleration or I use definitions. I will go with definitions. So let's find the velocity. What is the velocity at any time moment at time greater than 2 seconds? We know what to do. We take integral a of t dt. Acceleration is 0, so it is 0 plus constant, and we know this constant. It is 6 meters per second. Now we work with the position. What is the position? For the position, I integrate the velocity. Velocity is constant. It is, I will call it, how do I call, let's put 6 meters per second. 6 meters per second is constant, and this integral dt. So I have 6 meters per second times time in seconds for the position plus constant. And we need to find this constant, arbitrary constant. What is our constant? What do we know? We know x at 2 seconds. What is x at 2 seconds? The position of the object, I think I made a mistake. Yes. Here, find the car's position at 10 seconds. I will erase and put here 10 seconds because 2 seconds problem solved. So here is 10 seconds, nothing else has changed. Great, we're doing great. So, how to find this constant? I bring time 2 seconds because this is my initial condition now. That's what I know. At time 2 seconds, I bring 2 here. 6 times 2 plus constant. And this is equal to what? At 2 seconds, the position was 4. Can I calculate constant? Yes. What is this constant now? It is 4 minus 12. 4 minus 12 is minus 8. We are making progress. Now we know the position of the object at t greater than 2 seconds. I will emphasize it here. So the position of the object at t greater than 2 seconds is described by 6 times time plus constant, which is minus 8. So at any time greater than 2 seconds, I bring t here in this formula and I know the position. We are done. We found the velocity at any time moment greater than 2 seconds, and we found the position of this object at any time greater than 2 seconds. What does that mean for us? It means that I can write the final answer. And to do that, I will erase this real quick to write it in more compact form. So what is our final answer for part A? It is, we know that the velocity Vx as a function of time is equal to alpha t squared over 2 when we have t less than 2 seconds here, and it is equal to 6 meters per second when t is greater than 2 seconds. This is our velocity. What is our position? Our position as a function of time, it is alpha t cubed over 6 at t less than 2 seconds, and it is equal to 6t minus 8 at time greater than 2 seconds. This is our final answer for part 1. Vx at t and x at t for any time moment less than 2 seconds or at time equal to 2 seconds. Now, they ask us also to find position at time 10 seconds. Can we do that? Yes. So at 10 seconds, what will be the position of the object? Let me see. Can I write it here? X at 10 seconds. All I need to do, I need to bring 10 seconds here. 6 times 10 minus 8. What is this? This is 52 meters. We figure it out. Done. Now, just last note. Can you use formulas for constant acceleration to describe this motion at time greater than 2 seconds? Of course, you can, because acceleration is 0. Acceleration is 0, so acceleration is constant. Then why not to write the position using these formulas for constant acceleration? I want to do it, and where will I do it? I will do it right here at this t greater than 2 seconds. Give me 1 second, I will erase it here. Okay, I at time greater than 2 seconds. Oh, I erased too much because I also had here x at 2 seconds was 4 meters. Okay, now I'm ready. Acceleration is constant, velocity is constant. I'm writing x as a function of time. X as a function of time. Remember our formula for constant acceleration? What is it? It is ax t squared over 2. And this guy is 0. Why? Because acceleration is constant. Great. Plus, now I write initial velocity. What is my v naught x times time? V naught x is 6 meters per second. It is constant. I multiply time by time without thinking, and I immediately get into trouble. Because remember, our clock now starts at 2 seconds. So I have to write here t minus 2. Time is in seconds. T minus 2. And now, at time moment 0, or at time moment 2 seconds, I'm just fine. I will get my velocity 6 meters per second. Also, I need to add x at 2 seconds to have this formula written correctly. So here will be also x at 2 seconds. This is my initial position. And let's work with this formula. So what do we have? 6 times t minus 2. I think I already convinced you that we cannot go back. We start our clock at t2, so I can write just t greater than 2. And then plus x at 2 seconds, which is 4. What is this? 6t, 6 times time, 6 times 2. It will be minus 12 plus 4, which is minus 8. Of course, we have the same formula as here, this way or that way. If you do it right, you will get the same answer. I just wanted to show you different ways of doing that to have some flexibility.